Okay. So I'll share. Hold on.
Yeah, you might have to refurbish a little bit my basics on that Django. Okay.
Okay.
Think that I have not started. Okay.
Just the coverage.
Hmm.
I hope you can see my screen, right?
Yeah, I can see. Yeah.
So the Django program, we have various weeks and the lessons, okay?
Hmm.
The topics, okay? And what are the various module. Lesson 1 is like that, lesson 2. Okay, so lesson 1 is object-oriented programming concepts review. Okay,
Hmm.
so few topics are there, okay, and like object-oriented programming, review of that. Then we review Python's IDE. Okay, basically we are introducing the PyCharm IDE.
PyCharm. Yeah.
And Django relevant setup. Okay. Then we have setup and administration, which has a recap of application development framework, uh, ORM, CRUD, MVT concepts. Okay. Then introduction to Django framework. Okay. This has administration, Django site, admin site, so on. So this is lesson 1. Then it's sorted by lessons, and in week two, we go to Django framework where we create a Django app. We go into further template definition, the Django model form. We'll create a simple product form. Okay, so that's week 2, which is lesson 2 on Django framework. So these two are the week 1 and week 2 coverage. Basically, we recap the concepts and then go into Django framework hands-on. Okay, that's what we are doing in these 2 lessons. In lesson 3, we go into REST API, reviewing API. Okay, where you review the API concepts, JSON, a review of REST API, things like testing an API, JSON placeholder, and these are REST API concepts. Okay. Then lesson 4, week 4, Django REST framework. Here in Django REST framework, we look at introduction to what Django offers as a REST framework. Introduction to serialization, Django serialization. You create your own simple API. Okay. So this is lesson 4. In week 5, we go into Python automation. Okay. So here automation, SDLC, the web scraping, then image recognition, various testing frameworks like Selenium and robot test framework, PyTest. Okay, so these are some of the testing framework mostly used in under automations. Okay, in automations we'll see using various Python packages for testing. Okay, and this one specifically robot framework and PyTest. These are for the application developer. Okay, developer can test his own code with PyTest, and then he can use frameworks like a robot test framework for testing his code. Okay, we'll do some automated login testing and so on. Okay, this is week 5. It covers lesson 5 and 6. In testing, this framework is used by Wipro, robot test framework. Yeah. So, and Selenium is the common one. Okay. In week 6, we go into Git and GitHub. This is a version control system. Okay. And then we look at the concepts of branching, merging, and all that. And use of PyCharm IDE for Git. And following that, lesson 8, DevOps introduction. Okay, CI/CD, and there is one more software called Sonar Cloud, which is for basically quality checking of code. So this is what we are covering in.
That's freeware, huh? Sonar Cloud?
It is not, but you can still learn the concepts. There will be certain amount of code review, and it goes along with a continuous development. This is what CI/CD is. As you develop the code, you can release proactively code which is of prior quality standards checked. So that way you're releasing code in a clean manner, okay, in a bug-free manner that way. So some standard syntax checkings will happen. So that's what this is. It's called quality gates with Sonar Cloud. All this part of the program, GitHub version control goes with DevOps. DevOps is
Yeah.
mostly the term here.
Yeah,
So
this GitHub DevOps and I'm a little familiar, but
okay.
yeah, I've not pushed code myself, but Git or pushed code
Yeah.
but yeah, I understand these things. Okay.
So we look into all that. This
Okay.
is a specific product, Sonar Cloud. They use they're asking for, in terms of job, they expect these things. So when the way I designed this, I looked at some of the companies, what they're expecting as skill set for the tools in terms of DevOps, in terms of Python automation. That's how I put robot testing and Sonar Cloud there. So you will see them asking in the job description, do you have experience in these tools? So that's why this program is exclusively to meet such job requirements. Yeah.
Okay.
Okay. So that's the coverage. So
Okay.
I put some indicative dates here. This is the Django course. Okay.
Okay.
So this is the coverage. First, in today's session, we'll review concepts. This is Django lesson 2. Okay. And what is to object-oriented, we'll review. Okay.
Okay.
Once again, since it will be a recap. Okay. We'll just review it and then go into Django framework. Okay. So that's this lesson 1 and lesson 2. Okay.
Okay.
I have installed PyCharm. Okay.
I'm using the same computer, so I also have it installed.
Okay.
So the install. Yeah. Last time we installed, right? You remember, Raji?
Okay. If it is there, okay, that's good. Okay. Yeah, very good. So let's start. So it's a review only. So you have already gone through this part. Okay. Let me share the screen. Am I sharing the screen? Are you seeing the Django?
Yeah. I see the Django. I see now. I see the Django.
Okay.
8 weeks. Yeah.
Okay. Okay. It's never too late to be what you
So
might.
this recording is for me, or you also share this recording with the other students if they ask?
The way it works is this recording will be available to you. Okay. And you have to create your login into skillanything.com. Okay. Yeah. Once you register there, it's a free registration. Okay. And then I'll ask the admin to link your ID to this course. So then you will be able to see the recording. Okay. As
Okay.
now, it's a live program.
It's only on cloud, or is I can download the recording?
It's on cloud. It's on
It's on
cloud.
cloud.
So
Okay.
you can check. I mean, it's there available anytime. Once your
Anytime.
login is linked to this program, it will be
Hmm.
available anytime. Yeah. And
Okay, got you.
yeah. Uh, so skillanything.com is a platform from one of
Hmm.
my contacts.
Hmm.
We he has allowed me to use it for the other program also, Pythonista, where there are a few students.
Hmm.
In Django, you are the one. Okay.
Django, I'm the one. Okay.
So,
And what should be a roadmap, Ajay? I just want to know. It might be a little
uh,
premature. What should be the roadmap? Okay, I do course.
uh,
Then what should I do? Should I do a project? Should I, or
uh,
is it something that will unravel as we do the
correct,
course?
correct. So good question.
Hmm.
Same that contact, he has allowed me to see. He's got some products. Okay, he's
Hmm.
got
Hmm.
some products. After this 8 weeks, the objective is uh, his products are built on Django. Okay, so
Okay. Hmm.
there are features and all that which you can be a part of. There will be the project hands-on
Hmm.
where you can add the new feature, help build that effort. Okay.
Hmm.
So
Hmm.
that way, the objective is to have a hands-on along with this program.
Okay. Okay.
After learning, some of the products he has built, like it's called Coolaunch, like that. He has got some tools developed
Hmm.
in Django framework.
Hmm. Hmm.
Django framework, even Instagram is on Django framework. Okay.
Yeah, I heard that.
Uh,
Facebook is on. I heard Facebook. Is it Facebook also on Django framework? No.
Django framework. Yeah.
I
So
read about it.
then
Okay.
this guy, he also has put his product in Django framework.
Hmm.
There you can, it's already a data integration product. So on that you can add new features like that. So he has given me the whole project
Hmm.
where when upon discussion he's allowed me to use that project to be a part of this course. Yeah.
Hmm.
Uh, it's a company called Iris Idea. Okay.
Hmm.
And he's got few products basically in terms of artificial intelligence and data sciences.
Hmm.
So that's how even the Pythonista program is, then the Django goes along with that. So
Hmm.
I talked to him. He said, okay, whoever comes out of the program like Django, they can use this project to build it. It's their company product, but
Hmm.
they'll get a hands-on on after the course. Mostly that will help the program. So it's complementing to that. You know.
Hmm.
So
Okay.
so
Okay.
that's
I registered to Skillanything. Okay. As a student.
okay, okay. And then you can share that. I'll tell them. I'll tell them they'll link to. See, normally after this recording, there is an admin who goes through in case something has to be edited. He'll merge content and all that, and
Hmm.
make yourself available with the content. So at that time, he'll message me. I will inform you so you can see against your login that content. Okay. Because
Okay.
sometimes we have to edit the content that there is a admin for that. Okay. So let's get started. Any other questions?
No, no, no. I'm good.
Okay, good one.
We'll start. Yeah. Yeah.
So review of object-oriented programming, what we have seen,
Hmm.
here we have seen classes and objects, right?
Hmm. Hmm.
So classes are template of an object, and
Yeah.
object are
Hmm.
instances. These are
Hmm.
just
Hmm.
a quick recap. Okay,
Hmm.
so we've seen some templates and some specific objects.
Hmm.
Template, a class of blueprint of the house, like
Hmm.
that, and individual houses are specific objects. Same way, in this example, you have um, uh, various sketch pens here. Individual pens have their own properties, the color property. Okay, they have different colors, and there are methods where the pen can write. You can use it to draw. So we have like colors as property and write and draw as methods. So basically, a class combines property and methods. Okay. Here is another one. Paperclip can have a color. Paperclip is a class name, and color is a property. And there are individual objects of different colors. And the function, the method is clip paper. Okay. So there are a few types of class names here shown as example, each of which is a template, and they could have properties. So I've just put the list of properties against pen, could have a color, a book could have title, author, year as properties. And methods, you have write, draw, a book could have pages, publish, a car could have model, name and model, manufacturer, color as properties. You could have start, stop, accelerate, brake. So some of these are various classes, user, like username, password. Methods could be login, log out, person, place. So each of this, student, teacher, and so on. Okay, vehicle, animal, bird. Animal could have number of legs, a name, number of legs. Animal could run. Bird, number of wings. Bird can fly. So thinking in terms of class and class to have properties and methods, and then individual object. When you create an object, there is a relationship which is between the object and the class. That student one is a specific object of the class student. Okay, student two is another. In terms of object and class, they have a relationship like that. Object is a class. Teacher one is a teacher. Okay, student one is so is a type of relationship. And in inheritance, so you have student is a type of user. So when you have inheritance, you are using a parent class and its subclass or a child class are there. So here, that's the concept of inheritance. So student can be a type of user. The user here is a parent class. Student is a type of user. Teacher, type of user. So when you have a type of or a subtype of, that's inheritance. Okay, so here, see, cat is a type of animal. Dog is a type of animal. So cat and dog have inherited from animal class. So same way for bird. Like vehicle is your parent class. You can have car as a subtype. Okay.
We did this last time. I think we had worked on car and vehicle last time.
Car and bus and truck. Like
car and vehicle, yeah. Bus and truck,
so that's the inheritance. Okay. In instance, object classes have instance properties and method. That the class can have properties and method. Okay, an instance is an object have properties and methods. So here are class properties and object properties. So these are some examples. Classes serve as instance factories. If classes are like cookie cutters, instance is a cookie out of those classes. Okay. And then your classes are how you encode, you'll use this class keyword and then the name of the class. And then when you use the inheritance concept, you'll use the class name inside brackets. Okay, inside parentheses, that's the parent class name, and while creating your child class. So C1 here is your child class, C2, C3 a parent. And when you make instances of a class, L1 is equal to C1, L2 is equal to C1. That means these two are separate objects. Okay.
Mm.
Then, yeah, classes are really packages of functions. Okay.
So when we have these so multiple parent classes, and if there is a conflict, you explained to me last time, if there's a conflict between these classes, right?
Hmm.
How do you overrule that?
There is a method resolution order,
Resolution order method, yeah.
MRO, which will go through identifying the order in which you backtrace. Okay.
Backtrace.
So that's the method resolution order from left to right normally. So that's why C2,
Oh.
C3. Yeah.
Mm.
Basically,
So which
this is
means mm,
the classes is serving as a data type. Okay,
mm,
why do you need class? Okay,
mm,
it's because you're creating your own custom data type. Okay, there could be a
mm,
person class having first name, age, gender, first name, last name, age, gender. That whole record set will become a type, data type. Then from that class, you can create objects. Okay, student, teacher, that.
can you repeat that part? I think I
Yeah,
lost my focus.
here is a class example.
Mm,
So this name here is a
mm,
class person.
mm,
Okay. Then
mm,
I can say Prabhu is equal to person.
mm.
The person has
Person and curly braces, right? Sorry, normal parenthesis, correct?
yeah.
Uh,
But here, when you define it in code, you'll just
Not here, but in instantiate. Yeah. Okay. Yeah.
instantiate.
Mm,
Instantiate
mm,
will have parentheses. But
mm,
person, the reason we are defining this is
mm,
there is some properties here, name, gender, age. Okay.
mm, mm,
I'll
mm,
club these three together to
mm.
form my own data type. The name could be a string, gender could be a string,
Boolean. Mm,
this age could be a number like that,
mm,
but all three combined. So when you get to a complex data type, that's why
mm,
you define a class. Okay.
mm, 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 mm,
Then this,
mm,
this person is a data type.
mm.
Then you will say Prabhu equal to person parenthesis like that.
Parenthesis. Yeah.
So,
Yeah.
no, that's the way you instantiate the object. Okay.
Yeah. Mm, mm,
Now, here is a constructor. Constructor has a function. It's a initiation function.
mm,
Whatever we are passing the value, you have the self referring to the name of that object which will get instantiated at the time of instantiation. So
mm,
here you will initialize the value. Self
mm,
dot name is equal to name. So the value
mm.
you give here, that will go to
Yeah.
that
Mm,
object's name. So this is self is referring to the new instance of that object. This is a constructor. So constructor goes with a double underscore init. In Python, init with the double underscore is used as a first method of the class.
mm, mm,
So that's a constructor.
mm,
And the object reference is self dot attribute. Okay.
mm,
Self dot attribute. So self dot name, self dot gender, like that. Okay.
mm, mm,
So that's a constructor. Here is another one. Example, item.
mm.
Okay. Pencil is the object. And
Mm.
specific data you're passing. That's this pen.
Right.
Okay.
Right.
Pencil
Right.
box, specific data. So objects are instances of this item. Okay. With specific data. Okay. So
Mm,
that's the item class.
mm, mm, mm.
And vehicle class, like we saw this, like car, truck
Yeah.
is equal to likewise.
Yeah.
And
Mm,
once you create this object, you can do the data manipulation of it. You can read
mm,
it. You can do the CRUD operations. Okay, you can create the object. You can query the object, all that. So here it's
mm,
printing uh,
mm,
car dot manufacture. So it's printing, it's reading that object. Okay,
mm, 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 mm,
so that's this is another example. We're creating a class dog,
mm.
and you have the constructor always the first method,
Yeah.
and then you can
Yeah.
define your own methods like bark, fetch. Here in fetch you can see the self dot fetch count. It's the property here we are setting to increment by 1. Okay, so there are setters and getters inside. Typically in object-oriented programming, you will have the property here, and that property is having two methods, setter and getter. Okay, setter is going to set that value, getter will read the value. You will not expose the fetch count directly. So your uh, the method of having or the concept of having the property and the setter and getter methods is encapsulation. You're encapsulating this inside the class. Okay. So there is no object-oriented programming, there are concepts like encapsulation. Okay.
Yeah.
Which
So in this class, you have fetch count equal to 0. That means if that attribute is not passed, you take a default value of 0. Is that what it is? That on top, a fetch count equal to 0 mean?
fetch count is fetch count is equal to 0, but you are setting that with the fetch function here. Okay, so when you call fetch, it will automatically change the value of fetch count to increment by 1. Okay, so you don't have to directly set, you'll just say the object here, in this case, class is dog, so the object could be my dog, okay, my pet, dot fetch count, so that will increment. So you are protecting that, or you're encapsulating the properties and methods together into a class. Okay.
No, I didn't understand. See, now you said my dog. My dog is the object. So my dog is equal to dog in parenthesis,
Yeah.
dog comma and parenthesis, right? My pet dot. Okay.
So
Now you have. Oh yeah. Go ahead.
so
Sorry.
my pet is a specific pet, Toby. Okay. My brother's pet is another pet. Okay. So both are the dog class. So these are two objects. Now when I have to set a value of my pet, okay, of course that's in this object, but when I increment, when I say my pet dot fetch, it will increment that count, fetch count. So fetch count is going to be incremented each time. So that's what it says. Toby runs and fetches the stick 1 time. Another time I call fetch count, it will increment once again. So this is a setter method. Okay.
And this is defined in the class itself, the auto setting, auto incrementation.
In the class. Yeah, that's what we did here. In other languages, Java, they call it setters and getters. Okay.
Setters and getters.
Setters and getters, if you use IDE, it will generate the setters and getter method. But here, that's the same. They have the concept. We are setting fetch count, and we are getting, when you get, you're going to read a self.fetch count. So, for example, here self.age, self.name, it's reading the value. So here in this case, fetch count is using this method sit. So when I'm calling the sit method, we see the name Toby is sitting with so many fetches. Okay, so that's what Toby. Toby is sitting with 3 fetches. So you're getting the current value 3. Okay, so that's when you're using a getter method. So my pet dot sit and my brother's pet dot sit. Rover is sitting with 3 fetches. So that's a getter method.
So what you're saying is when you call those functions, my pet dot any function. So in the backend, it is encapsulated, but the count is you program the count to increment. Correct?
Yeah, you increment
every
the setter. Yeah, you increment the setter and you get the value with the getter method.
Getter method. And getter method does not increment. You are not coded to increment when it is a getting. Correct?
Getting is the reader. Basically, you're
right?
giving the current number, how many times it is already the current value. It could have incremented so many times, but when you're using it to fetch that total count, so that's a getter. Okay.
So can you show me that fetch function? Just me read the syntax example. Fetch is the get, right?
This is the setter.
Okay.
It's just the terminology. Yeah? So setter is the concept where you're setting a property. Okay. And getter is the concept where you're getting the current count. Okay. So I could
Sit is your getter and fetch is your setter. Huh?
Yes. Yes.
Oh, I thought I got a little confused. Okay. Fetch is your setter. Okay.
Fetch is setter. Yeah. It's actually dog is playing fetch. Okay. So
Got it. Okay.
imagine you're throwing the stick and the dog goes and fetches it back. Okay. So
Got it.
you have to set some property. So
Okay.
and you're incrementing that value.
So why is it so important, this setter getter as a function inside of code?
Actually, in object-oriented concepts, okay, they have properties which will change. Okay, so then the concept of a setter and getter is always required. So even an IDE, like for Java, it uses Eclipse. You can generate that. Okay, when you say fetch count, you can generate that particular setter getters. Okay, through code. Code templates will automatically, the moment you point fetch count, you can use the IDE to generate these values. So basically the property is encapsulated with its functions. That's what's, and both are combined. That's the concept of encapsulation in object-oriented, where the property is not set directly. You are using functions to access that particular property. Either you're setting it or setting the property, or you're reading the value or getting the property.
Yeah, okay, got it.
So then that's one concept of object-oriented programming. Okay. Now inheritance. Yeah. Inheritance is when one class is already there. Okay. Like vehicle class is already there. And we are using that as a parent class to a child class. So here bus is a child class, and all the properties and methods of vehicle class is available. When you use the inheritance concept, you invoke the parent class constructor with super dot init. So this is line 38 super dot init is used inside your current class, child class constructor. So inside the def init, the values which has been set to the bus class here, name, manufacturer, speed, will be set to the parent class. The parent class values are all going to set with this. So all the properties and functions of the parent class is available to the child class. You don't have to code inside the child class at all. So that's the concept of inheritance. Every code is available, this property and function is available in the parent class. And all you do in creating child classes, like here, in this example, bus class, truck class, we just pass the parent class name.
Now, if I want a couple of more parameters to be passed for the child class, besides this name, manufacturer, speed. So then what you do is you add here, is it?
You can add your own classes, your own properties here.
Properties, right? Yeah. Okay.
Yeah, you can
so,
add.
But then for the name, manufacturer, and speed, I don't need to add any code here. But for whatever new I'm adding, I have to add. That's it.
So the concept here is because of code reuse. Whenever we reuse code, the common elements are put in a parent class or a super class, and then called with this method, super dot, and that initializes everything. And so this is the inheritance concept. Okay. Of course, these are objects you can read and you can query and print the values and all. So this is inheritance. Okay, properties. And another example here is the story of movie Madagascar. He is Alex. He is a lion in New York, whereas his parents find him in Madagascar. Okay. So he shares the properties of the parent. Okay, Zuba and mom. At the moment in the movie, like, oh, he finds his parents in Madagascar. Okay, but the point I'm trying to make is common properties can be in a parent class here, lion. Okay, and here name, age are lines classes. I mean,
So
property.
Ajay, one question. So you told me something now. So
Hmm.
typically, when you want to have common properties among many people, then you define that common
Correct.
set of properties as a parent class,
Ah,
and then the other class you just inherit those
exactly.
properties, right? So if that's the case, then why do we need a child class? Why do
Ah,
we need it in the first place? What
Good
is that it's
question.
going to be?
Child
Hmm.
class can have its own properties methods additional on top of the parent class,
Hmm.
and
Hmm.
we can have uh, overriding methods. Okay,
Hmm.
overriding is the third concept. So
Okay.
first
Okay.
concept is encapsulation, second is inheritance, and third concept is uh, polymorphism. Okay,
Polymorphism. Okay.
polymorphism. Now,
Hmm. Hmm.
here is an example. The child class is line cub,
Hmm.
and lion is a parent class.
Hmm.
He can have overloaded, he can have his own properties. So Alex can only, he can't hunt, he can dance.
Hmm.
Okay. He's
Hmm.
having, so you can define your own methods here. But
Hmm.
when you come to overriding, okay,
Hmm.
overloading means that the same function is having uh, a different signature. Okay.
Okay. Hmm. Hmm.
Add
Hmm.
can have add two numbers, three numbers, four numbers, or
Hmm.
dynamic numbers.
Hmm.
So the same function having different signature is overloading.
Hmm. Hmm.
Overriding, here you would have uh, the same method
Hmm.
description.
Hmm.
Okay, is
Hmm.
called an Alex dot description. At that
Hmm.
time, you can write your own
Code.
extra code on that. Okay,
Yeah. Okay.
line up, you can write more code to override here. Okay, Alex is a 4-year-old is there. Alex dot description. Alex dot description is the method which is in the parent class. This is the inheritance concept. But
Hmm.
this
Hmm. Hmm.
description, you can write additional functions, extra line of code in the child class. So
Okay.
that is when it is overriding. Okay, overriding is a concept while using in classes where the
Yeah.
parent
So
class.
in this example, you have shown that description just print something, right? That's what I saw in the class, parent class,
Ah,
right?
correct.
But here,
Ah,
if I want to do some more calculation and
yes.
not print at all, okay. So I will write that code here
Ah,
in the method is in the description method here, and this will automatically override what is there
override.
in
Exactly.
the parent class. I
Correct.
don't need to say anything like please override. I don't need to say something like that. Correct.
Yes. Yes. You use the
Okay.
same name. Okay.
Same name, but
But
okay.
you could add some maybe additional lines of code in that. So
So
that's override.
additional line is what? That's what I know. So if I
New
add additional
function.
line, yeah, I'll add say there is one print. Then
Ah,
I'm here. I don't want to print in the child. When I call the child method in the child class, I don't want to print.
ah,
So, but that print is there. So I have to override that. I don't want to print. How do I
yes.
do it?
Yes, you can use the same name and write your lines of code.
Lines of code. Yeah.
Okay.
So, and if I want the union of both, that is, it should print there and then
Ah,
come here and do something else. Then I have to repeat the print command again in the child classes description method. Is it?
Its basic concept is reuse. Okay, so that
Hmm.
means maybe I'll write 100 lines of code in the parent. Okay,
Hmm. Hmm.
then that function, those features are available
Hmm.
to the child, and you
Hmm.
can enhance with new functionality in the child class.
Hmm.
Those lines of
Okay.
code are always available. Okay,
Always available. Oh,
it's
okay.
always available, and you can override here with like add can do um, some set of functionality, but you can add additional function in the child class. Child classes will have additional functionality. That's the purpose of inherit.
Okay, there you are just overloading then, basically, correct?
Or overriding. Overriding is only when the inheritance comes. Okay. Overloading is independent of inheritance. If you don't have inheritance, you can have within the same function. So polymorphic function is in the same class. But when you are inheriting is when it's overriding. Okay, so here I think we have, see the description in Alex child class would have some, I've just made a small tweak here. Here it's like 4-year-old cub. So then this description, when you use Alex, it will print 4-year-old cub. Okay, so that's your override.
Override. Okay.
Override the parent class. Okay.
So here you are printing Alex dot description. So Alex is the child, basically, line cub.
Correct. Yes.
Correct, right? Alex is the child instance of the child class.
Yes.
Right?
Yes.
So Alex. So when you print it, so if I had instantiated the instance of a parent class and use the same print, so it will call that code, whichever is there in the. It will not have the word cub in that. That's what you're saying.
Yes.
Okay, but if I want to print some, you said, right, the basic idea of inheritance is to reuse code. Okay, so if I have, I want to use some code which is there in the description, some part of the code in the description method in the parent class. Okay, and then and I want to use that. And I have not reworded it here. I have not recoded it here because I'm inheriting, right? So then I would say again print Alex and that particular method, right?
That specific method you can call out, which is in the parent.
In the parent.
Yeah.
Okay.
So that's the review, and multiple inheritance here is like class A, class B. This is the order in which it resolves is from left to right. Okay, left to right within the bracket. You have A first, then B. And then in another class D, B first and A. So when you have this concept of multiple inheritance, okay, there is also the method resolution order as a function, as one of the functions of the class. So in any class, if you have to see the backtracking where it goes into multiple levels, it will show which class is executed first and then the next. The class loading happens in an order.
Oh, okay.
Classes have a class loader. Okay, multiple levels. Let's say you have 10 levels of inheritance. It could be some project where you're having some base class and then parent, then child, like that. If you're going like that, so C at the lowest level dot MRO will tell how the backtracking happens. So there is a default function for it, MRO.
So what is the significance of this loading in sequence? What actually it does?
Because it could have got certain class which is available in both of these.
Right.
Some function could be there in both A and B.
Correct.
So which it took first, which it calculated first, then the final calculation, that order in which it backtracks, you can see with that. So common.
So if the description method was there in A and B, okay, in the first day A, there was a print line, and in the second one there was no print line. Example. Okay, so now I call in the child, I call the description function. What will happen? It will now that A is loaded before B, it will print, is it? Because A has the print.
Yes, it will print A, and at the next level of inheritance, it will see if there is a inside this particular print line inside B. It will go look at that particular class. The order in which it traverses the class. That's what this is like.
Yeah. So will it execute the description twice because it does the description there is there in A, it is there in B. but I have called it only once in the object of the child class. So what will it do? It will execute twice, is it?
It will load. Yeah, it will load in that order. Yeah, we are only saying that order it loads. It will execute what is there in that lines of code. In inheritance, all lines of code will execute.
All
That's
lines of code. Oh, got you. Okay, this only decides how the compile, basically how the sequence, all the code is sequenced. That's all.
only, yeah.
Oh, yeah. Because okay.
Executed with this order. And
We'll have this. Okay, got it. Okay.
Yeah. So the method resolution order is about that. And one more, the final concept of object-oriented programming is abstraction. Okay. So first we looked at encapsulation, which is combining properties and methods, and then inheritance. Okay. And then polymorphism, and the final one is abstraction. Abstract classes are like we see that a little down the line in terms of there is some, like, you have no definitions. You'll just have some statement like pass. See here, pass is still a Python line of code when you don't have to fill anything. You use that class name and you don't define anything. It is abstract. Okay, we just got that property, but then in abstraction, you could later take that name and then write the specific code. Okay, so that's the concept of abstraction. That means the class itself has got a name, like serializable. Okay, the serialization is just like a property. Okay, in terms of something like stockable. Okay, some properties you have just defined the name only, but your code is not defined. Okay, so that's called as an abstract class in object-oriented programming. But when that abstract class is there, you will not define anything until you use that particular class. Later, when you're writing the code for it, you use the actual code. So abstract classes are just empty templates. Okay, just the property name is like serializable. Serialization means you're putting the values in a stream, like a list. Okay, like when you're calling data, you could have a list of users asked by an API, and you are flattening, you're setting a serialization. Means that first user 1 comes, user 2 comes, user 3, the entire data is coming as one dictionary. Okay, flattening as a dictionary. When you pass in Python, your API is coming as a set of users. Data is coming as a string of a set of users. So that's term used as called serialization. Okay. So normally, when you're setting a set of, you're sending a set of rows through an API. That's so serializable is a property. Okay, it's like an abstract class defined.
Okay.
Here you'll code inside. So some examples of
maybe I need to see that. Maybe we didn't discuss abstraction in the last time. I'm not sure.
Yeah, it will come to later. Even other concepts are there called mixing and all that, but not specific to this point. But anytime you will see that some verb like that, stockable. In Java they call it interfaces. Interfaces are abstract classes. Okay, so there you can define something, and the actual code is further built down. So initial it's called an abstract class, and then the interface definitions are created later, like that. So Yeah,
I didn't
here,
understand much, Haji, but I will. If you're going to touch again, then we'll understand. Okay.
it's like in the class and in the object-oriented concept, some template is there which is not defined. It's abstract. Okay.
Abstract. So
There
you
is
have written here class A, pass. So pass means there is no code here. So, but that pass is an executable command. So, so there is nothing here. Then what do you mean? You will have it filled out later.
Yes, that particular class will have a definition later down. It's like the initial template. I'm just naming it and calling it as an abstract class. That's all to it. Okay. It is used in more like the development of the language itself, like that. Okay. Or if you are taking the concept of serialization, then that's an abstract class. Some property, some name. Typically, it's like a name, which is a function or a property. It's called later. It's not defined initially.
But it is defined later means at a later part of the program, you have that particular class A defined with all the methods and add properties, is it?
Yes, yes. At implementation time of the class, you could use that and then define. So that's when an abstract class is there. Normally not followed in too many scenarios, but in the development, you will see such category as well. Okay, but rarely these are some properties itself. If you see in Java, it's called they use abstract classes, and they use it called as interfaces. Yeah. So here Python, you will not see much of abstract classes. Okay. Very remotely you will see, but normally the main concept of inheritance, the polymorphism and encapsulation, these three, encapsulation, inheritance and polymorphism, this is what you'll come across in object-oriented programming concepts.
Got it. Okay.
So that's the quiz here.
Let's see. Let me try this. What is the difference between class and instance? We know class is blueprint. Instance is you create a working component out of it. Okay. How do you instantiate a class? You write the object name equal to class and parenthesis, correct? Correct. How do you access attributes of a class? Then class dot attribute.
Yes, class dot attribute. That's correct.
What's the method? Method is a list of commands which you can run.
Method is a function of that particular
function. Yeah, class. Function. It's a function. Yeah.
Methods. There are setter and getter methods. They all.
So what is the purpose of self? Self is for when you self will come along in the initial constructor. So along whatever attributes or properties are passed, it will assign it to the itself.
To that object.
To that object.
To that object. Self refers to that object which will get created from the class.
From the class. What is the purpose of init method? Okay, init is that constructor, right? To get that, yeah. That's the first method in the class. You told me that.
It initializes the value of that particular object. Okay.
Object. Okay. Basically, that's where you define self dot this property one should be this. Whatever you send, it should be assigned here like this, right?
Yeah. Self dot title is equal to title. Self dot name is equal to name, like that.
Yeah. Okay. Discuss how inheritance prevents code duplication. So you define the parent class inside the brackets and keep. Then therefore all those methods are available to the child class. So when I instantiate the child object, I just call whatever is in the parent class functions. I can call using the child object name. Alex dot description. You had something which is actually in the parent class.
Without writing code in the child, you can use the methods of the parent within.
Writing codes in the child.
Yeah, you just call the super, every code of the parent is available.
Basically, I don't write code. I don't need to write code. I can That is one method, right? I don't need to write code of that function in the child class. And when I instantiate the child object, I call the child, the parent function. I can run it as though it is part of the child class only, correct?
With the super keyword, you can
Mm.
instantiate the properties and methods of the parent and will be available in the child. That's
Oh, super.
code reuse.
Yes.
Yeah, if
Mm-hmm.
there are common lines of code, there are 2, 3 functions or some 100 lines of code in the parent that can be reused across multiple child classes.
Okay, maybe I should write code, man. That's the problem, right? I spend at least 2, 3 hours a day writing, then only I can get a handle. Yeah, then can child class override? Yes, you can override properties of parent, correct?
So, yeah.
Okay.
So, child class inherits all the attributes and behavior of the parent class. Yes, this is override to that. So,
Super.
okay, so this is okay. So then decorators. Now we will park here because
You're getting late for another call.
I have a hard
Yeah,
stop.
yeah, sure.
Yeah.
No
So
problem.
this deck I will share through email. Okay. I'll put it in one shared drive. I think I have your access of the. I mean, I'll create one shared drive in
In Google Drive, right? Yeah.
Google Drive and put this here. This will be a review for you. Okay. We'll continue in the next class with this decorators and
Sure. When should be the next class, Ajay?
yeah, that's a good question. We got to almost the end of it. Let me even just wrap
Let
it
me do one thing. Let me do the reading on decorators.
up.
Okay.
De
I'll come prepared. I'll read and come next time.
Decorators,
Okay.
the concept is like in mathematics, we have, see, Python comes from a mathematical background origin. Okay, so typically they wrote everything for targeting the mathematical functions. In maths, we have learned like f of x is equal to x squared, right? Now, then we have come across a concept like f of x, right? The function of a function, right?
Composite function, that's called.
So that
Pre-calculus, it's there. Yeah.
calculus, that is the same concept of decorators here. That means you will pass a function as an argument. Now here is the decorator as a template. This is called, in your function, it's wrapping another function inside.
Oh,
Then that's the f of x approach. And when this decorator is there, you can apply it on any target function. So with this at, okay. So I put this one, this picture of a cake which my wife bakes. The underlying cake is there is an underlying function. Okay. Then in underlying target function, you can apply the cream sprinkles decorator with the at symbol. That symbol
Oh,
is,
you can have multiple layers, huh? Multiple layers of decorators,
you
is it?
can have multiple decorators. Yes.
Oh,
So
okay,
here
okay.
at decorator is cream. So I created this example much like that. So the target function can have multiple decorators here. So here is cream and sprinkles can be applied. So then underlying function need not have any change. Just by applying this, it will wrap this underlying, this take this function as an input. And, all these lines of code, it could be like login, log out, all that can be directly applied without modifying the target function. Okay. So that's the, no.
Yeah, learning the concept is one thing, writing
Ah,
code is another.
yeah.
Okay, okay.
At the time of application development, you could have this function, the login to that function is there. Sometimes you want to authorize one more login, like so. This decorator comes in. Decorator, you will see, like in terms of development, there is a lot of examples, especially when in Flask, if you remember, the route was a decorator. I will.
You have
So,
told me, correct. You have
the
told me.
route
Yeah,
was a
yeah, yeah.
decorator. So that's the. I'll just take you to Flask one moment. Here is at app.route. That means my landing page is the backslash or the forward slash here, the forward slash applied on a function. So what it does in the framework for Flask is it links the incoming URL request for a specific request. It could be like landing page, could be a specific login, could be some success. Means I want to go to that page. Is linking to the view with that decorator. So in this case, Flask is allowing to use at app.route. So this is a decorator. Okay. It didn't modify anything here, but this login function is tied. You can see that the user's request coming in is tied to some view function. So that's done without modifying anything here. So these are some standard decorators, like get, post. These are parameterized ones. So app.route is the decorator. You can have any number of decorators like that. So that's one concept. You will see that across. So when you see what is this at, that's what it means. Okay, it means it's modifying the underlying function by adding some extra functionality. That's why you say f of the g of x is equal to function of f of x, like that. That mathematical concept.
Yeah. F of g of x, you tell that.
Like that. F of g of x are like that.
Yeah.
So multiple functions. So the next class, we'll start with the Django framework. Okay. What it can do. In fact, I didn't get to the PyCharm ID setup. If you, I think you
It's
have
already set up, but I might have to understand where your local drive is and all that.
What is to be the settings in PyCharm? We'll start with that. Okay, PyCharm specific to Django setting and all that. There are things we'll unpack it slowly. Okay.
Yeah.
Next class, you asked me. Next class, I think. Let me update you. Okay. Okay, Prabhu.
Okay, sure, Ajay. Let me know next class. I will read up decorators and I will talk again. Okay, sure.
Okay, you take care. Have a
bye-bye.
good night.
Yeah, bye.
Thank you.